3.4b, solving log equations. If I have natural log x is equal to 2, I'm in log form, so what do I get to do? What's my inverse operation? I e it. I exponentiate it. All right? So I exponentiate both sides. So now I get x is equal to e squared. If I wanted to round to 4 decimals, I'd put that into my handy dandy calculator. And what would we get? 3891? 3891. All right. All right, let's look at B. We have log base 3 of 5x minus 1 is equal to log base 3 of x plus 7. What property could I use here? One-to-one property. So now I end up with 5x minus 1 is equal to x plus 7. All right. And since we can do this from middle school, which way do I put my x's? I'd put them to the left. So how many x's do I have? 4. That's still kind of a lot. Is equal to 8. So x is equal to 2. All right. Let's look at part C. I have log base 6 of the quantity 3x plus 14 minus log base 6 of 5 is equal to log base 6 of 2x. What could we do? I can't use one-to-one property yet. That is a common mistake that I see from students. In a one-to-one property, we need one log set equal to another log. I can't use it yet. I will eventually. So what do I actually have to do? I have subtraction going on. What is that really? That's division. So I need to condense that log before I do anything. So when I condense that log, I now have log base 6 of the quantity of what? What goes up top? 3x plus 14, and then over 5 is equal to log base 6 of 2x. Now, what property am I allowed to use? Now I can use one-to-one property. So now I end up having 3x plus 14 over 5 is equal to 2x. Now, how do I start solving that? I multiply both sides by 5. So now I end up having 3x plus 14 is equal to 10x. Subtract 3x and we end up with 7x is equal to 14. X is equal to 2 again. All right, this next one. We have 5 plus 2 natural log x is equal to 4. We actually did kind of these on our homework yesterday. It was very similar to number 26 that we did. All right, so what do we do to start this thing? Inverse operations, what do we do? We subtract 5. So now I have 2 natural log x is equal to -1. Now what? Divide by 2. So now I have natural log x is equal to -1/2. Now, I have it in log form, so what do I need to do? E it. I exponentiate it. So I e both sides, so now I end up having x is equal to e to the power of -1/2. Now, technically, what is that? This is my childhood. What is that? I go to the basement. All right, so what's up top? 1 over, and that's really a square root e. So if I were to type that into my handy dandy calculator and round to 4 decimals, what do I get? Skipper, what do I get? 0.6065. Good job. All right. Now, technically what happened is we actually found intersections. All right. Technically, we set them equal just like we did in number 26 from our homework. We set them equal, and we actually found for where the x is on our intersection. All right. Let's keep moving. We have 2 log base 5 of 3x is equal to 4. 2 log base 3, or log base 5 of 3x is equal to 4. What do I need to do first? Divide by 2. So now I get a log equal to a number. So now I have log base 5 of 3x is equal to 2. How do we solve a log? A to the c is equal to b. So my a is 5 to the power of 2 is equal to 3x. So what's 5 to the power 2? 25. So now I have 25, and then what am I going to do to it? Divide by 3. And so x is equal to 25 thirds. All right. All right, let's look at this next one. I have log base. Doesn't have a base. So nothing. It's base 10. If it doesn't have it there, it's actually a log base 10. So I have log base 10 of 5x plus log base 10 of x minus 1 is equal to 2. So what do I need to do first? I have to condense this thing first. All right. So it doesn't explicitly show a 10, so I'm going to put it just to notate it. And then what does this addition thing mean? That means multiplication. So it's really 5x times what? X minus 1 is equal to 2. Again, how do we solve a log? A to the c is equal to b. So what's my a? 10 to the power of 2 is equal to my b. I'm going to go ahead and distribute that if you're cool with that. All right, so what is that when I distribute it? 5x squared minus 5x. All right. Now, what would I suggest you do right here? I would subtract what? I would subtract 100, so then I can get it set equal to 0. All right, so now I end up having 0 is equal to 5x squared minus 5x minus 100. Now, could you factor it just like this? Could you factor it with all this? What would I highly suggest you do first? I would factor out a 5. All right, factor out your greatest common factor first. It's going to make your life a lot easier. And so when I factor out a 5, I then am left with x squared minus x minus, not 25, but 20. All right. And so now I have this quadratic. And what do we like to do to quadratics? We like to f them up. All right. And so what does it f up to? X minus 5, x plus 4. And so when I set it equal to 0, I get x is equal to? 0. Okay, it's not 0. This is a common mistake that I see from you guys this year. This is not a variable. Okay, this is a constant multiple. It doesn't have anything. Okay, if it was a 5x, then I would have x equals 0. However, this is just a number. I'd get 5 is equal to 0. Is that ever going to be true? Never. Okay, so you're not doing anything with this 5. All right, so my answers are what? X equals 5 and x equals negative 4. All right, those are my answers. No, those are not my answers. Which one's my answer? X equals 5 is definitely an answer. However, what's wrong with x equals negative 4? If I actually substitute negative 4 back in, what happens? I get a log of a what? A negative. Can a log function evaluate at a negative? It can't. All right? So this x equals negative 4 is actually not a solution. It's called an extraneous solution. Mathematically, it gives me a solution, but technically, when I back substitute things, it doesn't work. All right? It's said to be an extraneous solution. All right? Do you think I'm going to do that to you on the test? I am. I'm going to try to trick you, but really, is it a trick if I'm telling you that I'm going to do it to you? All right? I'm going to make you look for that extraneous solution. Okay? All right. Again, if you see something that high of an interest rate, who are you going to call? That's right. Thank you. All right. All right. Compounded continuously. What does that mean? PERT. Okay, so I need my PERT formula. All right. All right. So it says, how long will it take my money to double? All right. Test question is going to be double or triple, remember? All right, so let's do this. So I need my A. What's this 500 thing? That's my P. And then I have E, and then what's my rate? 0.0675, because I need it in decimal form. They give it to me in a percent form. I need it in decimal form. All right, and then my time. That's what I'm solving for, is my time, how long it will take. Well, what's my A? 1,000. My A is 1,000. Why is it 1,000? Because it takes it to double. If I said it would triple, it would be what? 15,000. Now, what's your first step? I need to get E to a number. What is my first step? What do I have to do with this 500? I need to divide by 500. And when I divide by 500, what do I get? 2. I get 2 is equal to E to the 0.0675 t. Now, does it really matter how much you started with? Does it matter if I started with $1 or $50 billion? Does it really matter? It doesn't, because guess what? If it's time to double, we don't care about what we started with initially. That was going to be a 2. So what if I said it would triple? What would that number be? A 3. All right. What if I said it would half? All right. We're going to lose money. All right. That would be what? That would be 1/2. All right. All right. So now what? I have an exponential form. Now I natural log it. So I natural log both sides. So on the left side, I get natural log of 2 is equal to 0.0675 t. Now, what's my relationship on my right side? Multiplication. So what are we going to do? We're going to divide. So now I end up having natural log of 2 over 0.0675. And I don't know what that number is, so we need our handy dandy calculator. Angela, you got the number? What we got? 10.2688. All right. So it only takes over just a little over 10 years to double at that rate. All right, that's pretty good. That's pretty good. I wish my money doubled that quickly. That would be great. I need a reader. Cooper's going to read for us.
The retail sales Y in billions of e-commerce companies in the United States from 2002 through 2007 can be modeled by Y equals
that,
where T represents the year, with T equals 12 corresponding to 2002. During which year did the sales reach $108 billion?
All right. What we got to do? We need to find how long it was. So what am I going to solve for? I'm going to solve for T eventually. So what is this 108 thing? That's our Y. All right, that's our Y. So we're going to set equal. So now I have 108 is equal to negative 549 plus 236.7 natural log T. Well, what's my first step to solve for T? I add over 549. So I add 549, and what do I get? 657 is equal to this 236.7 natural log of T. Now what? Now I need to divide. So now I have 657 over 236.7 is equal to natural log of T. Well, now I have a natural log, and what am I going to do with this natural log? I'm going to E it. I'm going to exponentiate it. So now I E both sides, and so now I get T is equal to E to the 657 over 236.7, and I have no idea what number that is, so we need a calculator. Jacob's going to give me the answer. $0.0493. All right. Did that answer the question? That gave us T, but did that answer the question? No. So what year did it happen? T equals 12 corresponds with 2002. So when did this happen? What? Not 2018. 2006. It happened in the year of 2006. All right. What if the answer were 16.99? still 2006. It happened in December, obviously, of 2006, but it's still 2006. What if it was 15.99? Then it would happen when? It would be 2005. All right. Just because we're trying to round up and whatnot, it doesn't actually work when we do it with those years. All right, there you go. We have one more lesson. Finish up this chapter.